y squared equals 3 brackets 1 minus x. The point P is minus 2 minus 3. We need to find the tangent and normal. So y squared equals 3, 1 minus x. Let's get the vertex here. The vertex happens when x is 1 and y is 0. So when x is 1, so let's mark that off. And the x-axis is flipped around the other way, isn't it? So there's our parabola then. We can sketch it. For example, when you put x as 0 in here, you'll get y squared equals 3. So this will be root 3 up here, and this will be minus root 3 here, just to confirm that we got it the right way around. Okay, and so when x is 1, we can see here this would be 0, and y squared would be 0 to give us this vertex value here. So that's what we've got then. So differentiating then, so here, let's differentiate. Function of function rule, so 2 lots of y to the 1 multiplied by the something differentiated, divide dx, is equal to the constant, expand this bracket in our mind's eye, 3 goes to nothing, we've got minus 3x differentiates to minus 3 lots of 1, which is minus 3. That tells us then that dy dx equals minus 3 over 2y, which equals, let's put the y value in, which is minus 3, so you'll just get the minus 3's cancelling and leaving a half at P. So now let's do the tangent. So as far as the tangent's concerned then, we've got y minus the y value, because it goes through this point, minus 3. So that's a plus 3, is equal to m, which is the half, that's the gradient of the tangent, x minus the minus 2, so it's x plus 2. So that tells us then that y is equal to a half x. When you expand this bracket, leave the y there, then you'll get 2 times a half, which is 1, but move the plus 3 over to minus 3, 1 minus 3 is minus 2. So we're going to get a half x minus 2 as the tangent at minus 2 minus 3. So minus 2 is, say, there, and minus 3 is there. So we're going to get a tangent. So let's just mark that point there. That's minus 2. This is minus 3. This is the point P. And we need to draw a tangent in there. So let's do that while we're at it. So I'll just draw that in then. So I'm going to come back over here somewhere. So let's try it here. Like so. Okay, and we go up like that, don't we? So let's just put it in there roughly. Okay, there's the tangent. So that's the tangent there, and we can mark that now. Now we look at the normal. Let's turn our attention to the normal. Here we're going to have the same y minus minus 3 is y plus 3 is equal to the gradient of the normal, which is minus 2, because that times that gives minus 1, doesn't it, the products, and it will be x plus 2. What does that give us in terms of an equation then? Y equals minus 2x, that's how many x's we've got when you expand this bracket. Then we've got minus 4, but we've got a 3 to take over to become minus 3. Minus 4 minus 3 is minus 7. So we've got minus 2x minus 7, so it's going to come down here from up there somewhere. So let's draw that in as best we can then. So I'll have a go here, somewhere around here, say. So I'm going to draw it in here. And it goes right down there to minus 7, and that's the normal. So we can identify that as well. There's the normal, minus 2x, minus 7. So the intercept is down here at minus 7.